This lab explores the different variables used in Coulomb's law. It will lead you to explore the effects of different charges and the effects of separation. To do this, we will keep two of the variables constant while changing the third, collecting data for that third variable. Graphing the results should reveal the relationships, hopefully matching those of the form of the equation of Coulomb's law for a pair of charges separated by some distance. In the first part, you will keep the separation fixed as well as the value of one of the charges. The value of the other charge will be changed, and corresponding forces found. This will be repeated for two other different charge configurations. For Table 4, the values of the charges will be fixed and the separation varied, generating corresponding forces. If we plot the data for the first three data tables, we might expect a linear relationship between the charge that had a variable value and the corresponding force. If all the variables except one charge are all fixed, then you effectively have force on one side of the equation, an overall constant term, and a charge multiplied together on the other. Compare what this looks like to the generic equation of a straight line. Y is equal to mx plus b. In this case, b would be 0. The constant term would be a combination of Coulomb's constant, the separation squared, and the other fixed charge. You're going to check how the combination of charges, in particular the sign of the charges, may affect the overall result, if it does at all. You will get three separate graphs, one for each of the first three data tables. Have Excel provide you with the equation for the fit. Use the slope as outlined in the analysis section to find a numerical value of Coulomb's constant K, and use the appearance of these graphs to answer the questions in the questions section. For Table 4, the charges are fixed and the separation varied. Plot the separation against corresponding force and see if it is linear or not. If it isn't, it will be necessary to linearize the graph. There is a video in the folder for this lab of what this means. It is possible that the equation of the fit to the data will reveal what you need to do to linearize the data, but you can also use the form of Coulomb's law as a guide. Once the graph is linearized, you can have Excel provide an equation for the fit, then use the slope to find a numerical value of Coulomb's constant as explained in the analysis section. You can use the appearance of the graph to answer the questions in the questions section. To do the percent error calculations correctly, it is necessary to make sure that Coulomb's constant is calculated correctly in SI units, or you may end up with huge percent error values. The simplest way to do it is to make all your distances in meters, and therefore if you square them, the results will be in meters squared. All your charges must be in coulombs. You can keep them in scientific notation, or you can convert them to their decimal format, whatever makes the calculations easier for you. And the force is in newtons. If you make sure that all of the conversions are done before doing the graphing, then the constant in the linear equation used to fit the data should be in SI units. Excel can do some of the conversions for you. Create a column of separation in centimeters, for example, then put beside it a column in which you have divided those values by 100. If you need squared separation values, then do this in the next column beside this one. Excel uses a specific format for listing numbers in scientific notation. It is similar to that which is used for providing homework answers in McGraw-Hill that are in scientific notation. But in this case, it might be easier to put the charge values in directly from the data tables, and then on the next row, divide each by 1,000,000 to convert to decimal. What is turned in? All four graphs that are asked for must be included in the write-up. These would be listed one graph per page, taking up a full page. There are videos in the folder for this lab that explain what this means and how to do it. If you have to linearize any of the four graphs, that linearized graph must also be included. That could mean anywhere from 5 to 8 total graphs. There are specific calculations that you're asked to complete from the slope of all linear or linearized graphs, and a corresponding calculation of percent error between accepted values of Coulomb's constant and the value that you get from the slope values. And there are the data tables and the answers to the questions.